In this video, we're going to learn how to solve one- and two-step equations. We're particularly going to focus on how to lay out our method correctly because this will be very important as equations get more complicated and we can't work out the answer in our heads. Let's have a reminder of some key terms in algebra. 2x cubed is an example of a term. This is numbers and letters multiplied together, no additions and subtractions. 3x plus 2, where we are adding or subtracting terms, is an example of an expression. And as soon as we put an expression equal to something and include an equal sign, that's an example of an equation. Equation says that the value of the expression on the left must be equal to what's on the right. And remember, equations we can solve to find the value of a letter. So we know that the equal symbol means that each side must have the same value. So we can think about the equal symbol as a balance scale so that in order to keep either side of the equation equal, we need to keep the scales balanced. Therefore, whatever we do to one side, we need to do to the other. So if we have a look at this example, if I add 2 to the 4 on the left, making 6, it tips my scales. In order to keep my scales balanced, I also need to add 2 to the left-hand side to the a, which I would write as a plus 2. Looking at this example, if we tripled the load on one side of the scale, so let's multiply 4 by 3, that gives us 12, that's tipped the balance. To make the balance level again, we must also triple the left-hand side, which means we multiplied the a by 3, which would give us 3a equals 12. So we're going to use this idea of the equal sign being a balance, and whatever we do to one side, we must do the same to the other to solve our equations. Obviously, this is a very simple equation that I'm sure you could work out in your head, that x would need to be 5 in order to make x plus 3 equal 8. But let's think of it in terms of our balance scale and in terms of our proper method. So if we've got x plus 3, the whole idea of solving an equation is to get the x on its own on one side of the equal sign. So we want to get rid of this plus 3. In order to get rid of the plus 3, we need to take away 3. So the way we write this for our method is underneath in brackets, and I like to use a different colour for this, we write minus 3. That's my instruction. I'm going to take away 3 from the left-hand side. Because I'm taking away 3 from the left-hand side, I also need to do the same to the right-hand side. So there's my instruction in brackets in green. Taking away 3 from the left would leave me just x on its own, which is what I want, and 8 take away 3 is 5, so that gives me my answer of x equals 5. So we can see that equations can be solved by doing the same thing to both sides. We could either add the same thing to both sides, subtract the same thing from both sides, multiply both sides by the same thing, or divide both sides by the same thing. Okay, let's look at some examples. So these examples are on your notes sheet, so I'd either like you to have printed off the notes sheet so you can write down these examples and stick them in your book, or just write these examples straight into your book. So we have n minus 5 equals 14. Again, the aim is to get the letter on its own on one side of the equal sign. Okay, so we're always going to do the opposite, this is called the inverse, to get rid of the items surrounding the letter. So in this case, I want to get rid of the minus 5. So I need to do the opposite to get rid of the minus 5. The opposite of minus 5 is plus 5. So I need to add 5. To keep the balance, so imagine that equal sign is a balance scale. To keep it balanced, I need to do the same to the right-hand side, which means I need to add 5 to the right-hand side. So adding 5 to the left-hand side gets rid of that subtract 5, and then on the right-hand side, 14 plus 5 is 19, and that gives me n equals 19. And there's my equation solved. I've found the value of my letter. Okay, let's have a look at and write down a couple more of these basic examples. So in this example, I've got 3n equals 12. Now, I want to get rid of the 3. Now we need to remember that this 3n means 3 multiplied by n. To get rid of that multiplied by 3, I need to do the opposite, and the opposite of multiplying by 3 is dividing by 3. So I'm going to have to divide the left-hand side by 3 to get rid of that multiplied by 3, and I must do the same to the right-hand side. So the left-hand side I'm just left with n, and on the right-hand side 12 divided by 3 is just 4. So my answer is n equals 4, and we can easily check that answer in this case because we know that 3 multiplied by 4 does indeed give us 12. Let's have a look at another one of these then. So this time I've started off with n. With the fraction line we know that means divide, n divided by 2. We want to get rid of that divided by 2. What's the opposite of dividing? It's multiplying. So I need to multiply the left by 2. Therefore, I need to multiply the right by 2. Now remember that multiplying the left by 2 gets rid of the divided by 2. So with fractions we can think about it as multiplying by 2 clears the fraction or gets rid of that denominator. So what I'm left with on the left is just n, and on the right I've got 6, follow my instruction, multiplied by 2, I get n equals 12. Again, we can check our answer is right. 12 divided by 2 does indeed equal 6. Okay, what I'd like you to do now is pause the video, find the sheet attached to the assignment, 1_1-step equations, and I want you to try some of these one-step equations. The answers are here. I'll leave them up, but you will also find the solutions attached to the assignment as well. This shouldn't take you more than about 10 minutes, so pause the video, do these questions, and then come back to the video for the two-step equations. Okay, so moving on to two-step equations means that we're going to have to do slightly more work to solve the equation. If we have a look at this equation, if we look at the left-hand side, let's look at how that left-hand side was created. Okay, we can see that first of all we multiplied by 3, so we multiplied the x by 3 and then we added the 4. We know we must have multiplied by 3 first because BIDMAS tells us we multiply before we add. So the aim still is to get this x on its own on one side of the equals. So we gradually need to unpick the plus 4 and the multiply by 3. So what do we unpick first? Do we unpick the plus 4 or the multiply by 3? Well, we are working backwards when we're unpicking, so we have to do BIDMAS backwards. So we will unpick the plus 4 first. Again, we need to do the opposite of plus 4, which is take away 4. So write our instruction in green and then follow the instruction. Taking away 4 from the left gets rid of the plus 4, so I'm just left with 3x. Taking away 4 from the right, 19 take away 4 is 15. So that's step 1, take away 4. Now I want to get rid of this 3 in front of the x, which is x multiplied by 3. The opposite of multiplying by 3 is dividing by 3. So remember, dividing by 3 gets rid of the 3 in front of the x, and then 15 divided by 3 is 5. So there's my solution to my two-step equation. Now I realise we could have done this in our heads, but it's very important that we have this layout and we use our balance method, doing the same to both sides, doing the opposite each time, because what we're going to look at now is how we solve equations when the solution isn't going to be a whole number, so we can't easily do it in our head. So again, this one I'd like you to write in your exercise book. It's on the note sheet if you printed it off. If not, you can just copy it into your exercise books. So this time we've got 15 equals 4x minus 7. So the x term's on the right, but that's absolutely fine. It doesn't matter, and I can leave the x term on the right all the way through. So again, I've got to unpick the minus 7, and I'm going to unpick the multiplied by 4. I'm doing BIDMAS backwards, so unpicking the minus 7 first, I need to do the opposite of minus 7, which is add 7. Do the same to both sides, so we've got to add 7 to both sides. So working on the right hand side, adding 7 is going to get rid of that minus 7, so I'm left with 4x, and then 15 plus 7 is equal to 22. Now for the second step, Because I've now got x multiplied by 4, I know to do the opposite, I need to divide both sides by 4. Now 22 doesn't divide by 4 and give me a whole number, but that doesn't matter. So the right hand side first, the dividing by 4 gets rid of the 4 in front of the x, so I'm left with x. And then we write 22 divided by 4 as a fraction. So remember, work top to bottom, write it as you say it. 22 divide, that's my fraction line, 4. So my solution is x equals 22 over 4. So we never ever give answers to equations as decimals. We always leave them as fractions, normally just as a top-heavy fraction, but it is good practice to simplify our answer, so we can simplify 22 over 4 to 11 over 2. Okay, I'd like you just to pause the video for a moment and have a go at this equation here. So pause the video, try it for yourself, and then you can restart the video and I'll write up the solution and you can see how you got on. Okay, my last step, I need to divide by 4. I've got minus 17 divide 4. So this time I'm left with a negative answer and a fraction. That's absolutely fine. And remember, if I'm dividing minus 17 by 4, I've got a negative divided by a positive. So overall, I'm expecting my answer to be negative, which is why I've got that minus sign there. Okay, let's have a go at a couple more examples. So this one again, right on your notes sheet or in your exercise book. This time I've got a fraction in as well, but that's fine. We can still apply the same steps. I want to get the x on its own. I want to get rid of the 3 which has been added and the divided by 5. So again, deal with the 3 that's been added first by subtracting 3 from both sides. That gets rid of my plus 3, so I'm left with x over 5 equals 28 minus 3 is 25. So remember, when we've got a fraction, that's a divide, so this is x divided by 5. So doing the opposite, I have to multiply both sides by 5. So remember, multiplying the right hand side by 5 clears that fraction, gets rid of that denominator, so I'm left with x, which is what I want, and 25 multiplied by 5 is 125. One more to have a look at involving a fraction. So this time my x has been multiplied by 2 and divided by 3. Now in BIDMAS it doesn't actually matter which order we multiply or divide in, so it doesn't actually matter whether we undo the multiplying by 2 first or the dividing by 3 first. It's normally easier though to get rid of the fraction first. So first of all, I'm going to times both sides by 3 to get rid of this divided by 3, remembering that's going to clear my fraction. So clearing my fraction, I'm left now with 2x equals, don't forget to follow your instruction, 4 multiplied by 3 is 12. Now I need to do the opposite of multiplying by 2. So I'm going to divide both sides by 2. And I'm going to be left with x equals 6. I could check this answer by substituting x back in. 6 times 2 is 12, divided by 3 is equal to 4. Right, now I'd like you to have a practice at some two-step equations. So you need to find the two-step equations worksheet that is attached to the assignment, and you can start on the challenge or the super challenge. Start on the challenge or the super challenge, and hopefully some of you will progress onto the hyper challenge. The worksheet looks like this, and you'll find the solutions here look like this. Okay, so I will go back to the challenge, super challenge or hyper challenge questions, but these are also detailed in the assignment.